Hi, and welcome to the next segment of VDOT's Just-in-Time Training for Balanced Mix Design. I'm Stacey Diefenderfer, and I'm a scientist at the Research Council. I'm going to be talking today about VDOT's BMD approach. First, let's look at the timeline for initial implementation. We started the evaluation of balanced mix design back in 2018, and we're trying to find laboratory tests and criteria to address the cracking, rutting, and durability. Moving forward, we've had over 2 years of field projects for research, and here we are mid-2021 and looking closely at an initial implementation date of 2023. For the 2021 specification, we have 2 BMD mix types. The first is performance plus volumetric, or P plus V. These mixtures must meet volumetric and gradation requirements in Section 211, as well as performance requirements from the special provision. Performance only, or P mixes, must meet the performance requirements in the special provision. However, the volumetric and gradation requirements in Section 211 are waived. This doesn't mean that there's not going to be any control over the mixes, however. Production tolerances from Section 211 will be applied to the job mix formula gradation and properties for acceptance. The performance tests that will be performed as part of the BMD effort include the Cantabro mass loss test for durability, the asphalt pavement analyzer test for rutting, and the indirect tensile cracking test, or IDTCT, for cracking. In addition, the TSR test is actually a performance test for moisture susceptibility. However, that's already included in Section 211.02. The Cantabro test is our mixture durability test. This test was originally used for porous friction courses. In order to perform the test, you will take a volumetric gyratory pill, determine the initial mass, tumble the pill in the LA abrasion device without the steel spheres, and then measure the final mass afterwards. Less mass loss will result in increased durability of mixes. For the asphalt pavement analyzer rutting test, you'll be making test specimens that will be tested at a test temperature of 64 degrees C based on our baseline binder grade of a 64S-22. To perform the test, we apply a steel wheel to a pressurized hose. The wheel load is going to be 120 pounds, and the hose pressure is 120 kPa. We then measure the rut depth after 8,000 cycles. Lower rut depth results in increasing rutting resistance. For the IDTCT test, it's very similar to a TSR or a Marshall test. A smaller pill is used as far as thickness, but it's applied with a linear load, constant load to failure. Then the load versus displacement curve will be analyzed and will determine the cracking test index, or CT index. A higher CT index results in a less crack susceptible mix. The performance test criteria in the special provision are laid out in a table. The rutting test is performed in accordance with AASHTO T340 at a test temperature of 64 degrees C. You'll be producing 4 specimens at an air void of 7 plus or minus 0.5%. The criteria for the rutting test is that it be less than or equal to 8 millimeters. The Cantabro test is performed in accordance with AASHTO TP108 at a test temperature of 25 degrees C. The test is performed on 3 volumetric pill specimens. The air voids are reported, and the mass loss must be less than or equal to 7.5%. The CT index test will be performed in accordance with ASTM D8225. This is again at a temperature of 25 degrees C. You'll be testing 5 specimens with an air void content of 7 plus or minus 0.5%. The CT index must be equal to or greater than 70. As you're doing mix design, lab-produced mix must be aged at the design compaction temperature prior to compacting. For the Cantabro and APA pills, this is 2 hours of aging. For pills tested for the CT index, it will involve 4 hours of aging. The purpose of BMD is to balance rutting and cracking susceptibility of a mixture. The idea is that we want to minimize the rutting and increase cracking resistance. We're going to be looking for a rut depth in testing less than 8 millimeters and a cracking index, CT index, greater than 70. You can see this in the green shaded box. These mixes should be crack resistant and rut resistant. If we have too much rutting, or too much asphalt in the mix, or too much rutting in our testing, what we find is that we may be more crack resistant, but we will have rutting susceptibility issues. If the CT index is very low, we're going to have a crack susceptible mix, though these mixes may be very rut resistant. To do this, we will optimize the asphalt binder content. The green shaded area shows what our target is in terms of test results. You can see in the blue mix that a 5.6% AC content, while passing the rut depth test, did not meet the CT index. That mix needed more asphalt in order to meet the criteria. At 6.1% asphalt, it worked quite well. You can see the result of over asphalting in the orange mix. If you have a mix that should be optimized at approximately 6% asphalt, and you have an actual over asphalted to a 7% AC, you're going to be exceeding the rutting while showing very good cracking. But you have to meet both specifications. When you're submitting your balanced mix design, you'll be submitting typical submittal information to your district. In addition, you'll be submitting performance data for both your control mix and your BMD mix. Keep in mind that the BMD mix must show improved performance over the control mix. That means less mass loss, less rut depth, and a greater CT index. For performance testing, you're going to be submitting each result at multiple asphalt contents. Cantabro mass loss is submitted at design asphalt and design minus 0.5%. CT index will be submitted at design AC and design plus or minus 0.5%. APA rut depth will be submitted at design and design plus 0.5%. What these do is give an idea, as asphalt content varies, which we know it does during production, what we can expect in terms of the performance testing results. As you're designing, you may want to keep in mind that you want to have a little bit of cushion built in your design for production variation. In addition to these, the aged CT index must be submitted at the design asphalt content. The aged CT index gives us an idea of what the long-term performance of the mix should be. It also allows us to evaluate rejuvenators or additive performance over time. After aging, rejuvenators and additives may significantly change your performance, and not in a good way. If a rejuvenator is not designed such that it continues to modify the mix correctly after aging, your cracking index could drop off drastically. The long-term oven aging is applied after 4 hours of short-term aging. To apply the long-term oven aging, you'll spread the loose mix in a shallow pan. The thickness of that loose mix should be roughly your nominal maximum aggregate size. Age the mix in a forced draft oven for 8 hours at 135 C or 275 Fahrenheit. Then reheat to compaction temperature and compact. For 2021, the sampling and testing frequencies are closer to that they have been for previous research testing. You'll be dealing with a typical 4,000 ton lot size. You'll be testing CT index and Cantabro for quality control, quality assurance every 1,000 tons. You'll be making pills for VDOT testing of CT index, Cantabro, and rutting every 2,000 tons. In addition, when the 2,000 ton sample is collected, we are asking for a research loose mix sample, 6 boxes of material filled completely full, please, so that we can do reheat testing and look at the impacts of reheating mixes on the performance properties. I hope this has been very helpful to you, and we'll see you out in the field. Thank you.